Let's get some practice with calculating expected value and standard deviation. So here we have this distribution based on the number of repair calls that an appliance repair shop may receive during an hour. So we can see our X values of, this would be the idea of 0 calls, 1 call, 2 calls, or 3 calls within that hour. And then we have the matching probabilities. So getting 0 calls within the hour has a 10% chance of occurring, 1 call is 30%, 2 calls is 40%, and then we have this blank piece that we're going to fill in here. So filling in the table, if we have missing information, which to have one of these tables, the missing information will come in this probability section, and it's the idea that all of those values, all of your probabilities have to add up to exactly 1. So to represent 100% of your sample space. So what we could do is think about how much we have covered already, like 0.1 plus 0.3 plus 0.4, which is 0.8. So the idea is that we have 80% of our sample space covered, and basically the leftover between 1 and 0.8, so thinking about the difference of 1 minus 0.8, that will be what we need to fill in the blank right here, which would be 0.2. So if you have missing information, just use that idea that all of those should add up to exactly 1. All right, expected value. So how many calls should the shop expect per hour? This is where we want to calculate expected value, or our weighted average. So what we're going to do is use the idea that we want to take each X value times its probability and add up with the next one and next one until we get through the whole table. So expected value, we're going to take 0 times 0.1 plus 1 times 0.3 plus 2 times 0.4 plus 3 times 0.2, which will be 1.7. So there's our expected value. We'll want to make a sentence for this, but I'm actually going to wait until we get standard deviation because those go nicely together in a sentence. All right, standard deviation. So what we want to do is average those squared deviations. So what we want to think about is the idea of taking each X value minus the mean, or that expected value squared, times its probability. So I'm going to do is set up the table like I showed in the example before. So I want to think about my squared deviations times their probabilities. So starting with my first X value of 0, 0 minus our expected value of 1.7, which is squared, and then multiply by its matching probability, which was 0.1. Then I'm going to do this for my data value of 1 times its probability of 0.3, data value of 2 minus the expected value squared, times its probability of 0.4, and then 3 minus the 1.7 squared times its probability of 0.2. And what I want to do is add up those values. So I want to take those and add them up. And if I do that, that will tell me the variance, which will go to a calculator, plug those in, and you should get out a 0.81. And what I recommend doing if you're feeling uneasy with the calculator is pause the video right now and go ahead and try and plug those in and make sure you get the same solution out. So that gives us variance. To get the square root, to get the standard deviation, we need to take the square root. So for standard deviation, we'll take the square root of that 0.81, which is 0.9. So to make a sentence, it's the idea that we expect this value of 1.7, and on average that'll differ by 0.9. So what I could say is the shop can expect about 2 calls each hour, and on average this will differ by about 1 call. per hour. So, mean standard deviation, using our new form of calculating, taking into account our probabilities, but then making a sentence is very similar to what we did before. All right, just to kind of review some probability questions that we could ask. So the probability of getting 2 calls, so we could just look that up on the table. So 2 lines up with a 0.4. So we could say there is a 40% chance they get 2 repair calls. Probability dealing with at least, so they're telling us the smallest value, so this is the same as more than or equal to. So with this, we want to look at what's the probability of being more than or equal to 1. So with our table, what we want to combine is we'll include 1, and then we want everything larger than or equal to that. So it's going to come from adding up those probabilities 0.3, 0.4, and 0.2. Which will be a 0.9. So there is a 90% chance they get at least 1 repair call. And then our last one here, what's the probability they get at most 2 repair calls? So this is the same as less than or equal to, since they're telling us the largest value. So with this, we want to look at probability of x being less than or equal to 2. So what we'll do is on our table, 2, we want to include 2, and then have everything below. So we want to add up those probabilities of 0.1, 0.3, and 0.4. So, which will be 0.8. So there is an 80% chance they get at most 2 repair calls. All right, let's look at one more example here, and this is a common application of what we're using. It deals with insurance companies and them having an idea of probabilities dealing with certain types of accidents or what they're trying to cover for their policy holders. And then they'll also have an idea of, on average, how much they're paying out. Taking into account those ideas, that's how they figure out what to charge you for your premiums. And yeah, so let's see how this comes together. We have here is an auto insurance company, and they estimate that a particular customer has a 1.5% likelihood of having an accident in the next year, with an average insurance payout being $10,000. And what we're going to see is the company charges this customer an annual premium of $500. So we want to see what's kind of the expected value of this insurance policy. And we're going to look at like how much is the company making off of this deal. So making a probability distribution table. So we haven't made one of these yet, but it'll be combining your X values and your probabilities. So what we're interested in here is what's happening with this insurance policy. And for our X value, what we could have this represent is the payout. So how much is the insurance company paying out to its customers? So there are 2 types of customers here. There are those that are having an accident and need to use that payout of $10,000. And then there are those that don't have an accident. So there's no payout. So what we'd have for our 2 X values here is we'd have that they could pay out $10,000, or if they don't have an accident, then they don't have any payout to worry about. So that would actually just be $0. So these are, we're very much simplifying this here, but for this auto insurance company, this is the 2 cases. So they tell us that this probability of them having to do this $10,000 payout is 1.5%. So this will be a 0.015, which means the probability of no accident, we just need to think about the complement. So 1 minus 0.015, which is a 0.985. So now we have this table that shows this 1.5% chance of having that $10,000 payout, and then this 98.5% chance of no payout. So let's talk about expected payout. So what we can do is, with this information, let's say we're in the shoes of the insurance company and we want to know, on average, what do we expect to pay out to our customers? If we have this data in terms of percent of them having an accident and knowing this average payout. So expected value then would be that 10,000 times 0.015 plus 0 times 0.985, which is 150. So what this value tells us is what the company expects to pay out for each policyholder in their account. So let me write that down for us. So the expected payout from the insurance company to each customer is $150. Now, with this, what can be kind of interesting with these problems is at no point are they just giving their customers $150. This is the idea of a long run average. So over many years of having this set up and these percentages, it's the idea of what can they expect to occur in terms of a payout for each customer. It doesn't mean they are going to pay out $150 to each customer, just means expected over a long period of time, basically how the money will behave in the long run. So now we know what we expect to pay each customer. Now let's think about how the annual premium comes into account. What they're charging, is $500 to each customer. So what we could think about here is the idea of loss and profit. And I'm just going to put this off to the side here. Thinking about making or losing money. So loss would be the idea of them losing money, and then profit would be the idea of making money. Now to figure out these values, what you'll want to do is take what the earnings are minus the cost, or revenue minus costs. Like, what's the money coming in minus what's the cost of doing whatever you're doing. If you take this difference and it comes out to be positive, that's going to link to the idea of profit and making money because you'd be earning more than the costs that are being incurred. If it comes out to be negative, this would be interpreted as a loss because the costs are higher than the revenue and you'd be losing money. So for our case here, if we're the insurance company and we want to get an idea of are we profiting or losing money, our earnings for a single customer is we're making $500 from each customer. The cost that's being incurred from each customer is this expected payout of we expect to pay out about $150 for each customer. So in terms of profit, which we'll have here in the difference, but you could even just set it up of we're making $500, we're taking out the $150 expected cost. So what we're going to end up with here is positive $350, which means we're making a profit. And this is what the insurance companies absolutely do. What they'll figure out is what's the expected cost of having you as a customer, and then they'll add some on. I'm sure there's many more values that go into thought in terms of making this 500 in terms of paying employees and all sorts of operational costs, but they're going to bump this up so that they're making a profit off of you. So what we could see here is that the insurance company can expect a profit of $350 on average from each customer. So with this question, a lot of pieces come through in terms of setting up your probability distribution table. You want to think about the possible outcomes, and sometimes even do this of writing in words, but your values for X should always be numbers. So there should always be a number associated with it. And then in terms of probability, in this case, they gave us the percentages. In the next video, we'll look at a case where we calculate the probabilities based on tools we learned before. And then in terms of expected profit, first we had to figure out like what's our expected cost in this case. But once you have an idea of earnings and cost, you can look at the difference between them to see if you have a loss or a profit.